Hello, Caymans. Mr. Eicher here. We're looking at a lesson about adding or subtracting rational expressions, ones that we'll need to factor first. But before we do that, just wanted to review the previous lesson about adding or subtracting rational expressions when you don't need to factor. So if you'd like to pause the video and try this warm-up question to see how well you're understanding the previous lesson. So the idea when you're adding or subtracting fractions, say if you had 1/3 plus 2/5, you need to make sure that you have common denominators, or that the denominator is the lowest common multiple between the two denominators. I like to think of it as sharing. So this 1/3 needs a 5 to match the 5 over on the second fraction. But if you're going to put a 5 in the denominator, you have to make sure you put a 5 in the numerator so that it's an equivalent fraction. But now the second fraction, it needs a 3, so just sharing, everybody gets the same thing. And then we could write this as 5/15 plus 6/15, and now we have common denominators, and we just add the numerators to get 11/15. We do the exact same thing here with rational expressions. For this example, I notice there's a 5 and a 10, so the left fraction would need a 2. 2 times 5 is 10. Now they both have a 10 in the denominator. The left side, the left fraction has an a cubed. This one has an a. So to be fair, they both should have the same amount of a factors. So the one on the left has a cubed, this one has a, so the fraction on the right would need an a squared to catch up, just to be fair. So now they both have an a cubed. The fraction on the left has a b squared, this one has a b, so the one on the right needs a b. And we need to multiply the top and bottom to include that. So then we would get a lowest common multiple, or also known as the lowest common denominator, same thing. It would be a 10, an a cubed, and a b squared. So we could write it as 10a cubed b squared, and the numerator would be 8, that's 2 times 4. The other numerator would be 9a squared bc. And we have common denominators now, so just like whenever we made common denominators over here, we just have one denominator and we add the numerators. We have a final answer of a denominator 10a cubed b squared, and in the numerator we have 8 plus 9a squared bc. The numerator, you could switch that. You could put the 8 at the end, the plus 8 at the end. But this is the basic idea of adding rational expressions. Let's look at a little more complicated. Now these we're going to have to factor first. As you can see, that's our main point of today's lesson, is making sure you factor before you add or subtract. So let's factor the denominators for both of these. So m squared minus 4 is a difference of two squares. That would be m times m, and we have a minus 2 and a plus 2. Let me give myself a little more space here. And on this denominator, we have a greatest common factor. The greatest common factor between 3m and 6 is a 3. So we could factor a 3 out, and we have m plus 2. Now let's kind of go through the process and see what both fractions need to have identical fractions. So the one on the left, if we include a 3 here, that would match this 3. So we'll multiply the top and bottom on the left fraction by 3. On the right, it has an m plus 2. So does this one. So we don't need to multiply at all. We don't need any extra m plus 2's. But on the left, we do need an m minus 2. M minus 2. There we go. So now we would say the lowest common multiple, or the lowest common denominator, same thing, is 3m minus 2 m plus 2. So we would have one common denominator now, 3m minus 2 m plus 2 over, now we're going to be adding these, 3m plus, distribute here, that would be 2m minus 4. So how do we write our final answer? Our final answer, we're going to leave the denominator factored. So we're going to leave the denominator as m minus 2 m plus 2. You might be tempted to multiply that, but you don't need to. I'd actually recommend not multiplying that out. And our numerator is 5m minus 4. That 5m minus 4 doesn't match any of the factors in the denominator, so that's all good to go. So that is our sum of those two fractions. Let's look at number 3. Number 3 is another one that we have to factor. We know we have to factor it because we have a trinomial and we have a binomial that it looks like it has some common factors between 5 and 10. So to factor, give myself a lot of space here. To factor the denominator on the left, we're going to have x times x is x squared, and we need factors of -6 that will get us to -1x. So that would be, let's see, not 6 times 1, so a 3 and a 2 is going to have to work for us. That would be a -3 and a +2. The numerator there is still x minus 1, and then we could factor the fraction on the right to be 5 times x plus 2. Now again, we go through the process of matching factors. The one on the right has a 5, so we need a 5 on the left. And they both already have an x plus 2, so we don't need any extra factors of x plus 2. They already match. That's good to go. But the one on the left has x minus 3, so we need to multiply an x minus 3 on the right. X minus 3 in the top and bottom, so it's an equivalent fraction. So we would have one common denominator of 5x minus 3, x plus 2, and we would have, we can distribute the 5, so that would be a 5x minus 5, and we have a subtraction here. And I'm going to distribute the negative with the 4 to each one. So -4x, and then -4 times -3 is plus 12. Be careful about that. That's a common mistake there, to miss the sign. Anytime there's a negative, you have to make sure you distribute the negative. So it looks like we would have in the numerator an x and a +7. In the denominator, we have that common denominator, like so. And the x plus 7 can't divide at all. It's stuck as x plus 7. It doesn't match either of the factors in the denominator. So that's our answer. I'd like you to try number 4, and you're going to have number 6 as well. If you'd like to pause the video and try those now, that'd be excellent. But let's look at number 5 for one more practice. We do have a difference, so we're going to have to be careful about distributing that negative. And we also have a binomial that's 6 and 18. We should be able to take a greatest common factor. And it looks like 4, 14, and 6 has a greatest common factor, but maybe before we try to factor that. So let's see what that looks like. We would have a 6 that we factor out, and we're left with x minus 3. And let's take a 2 out. That would be 2x squared minus 7x plus 3, x minus 1. So that was pretty good. We still need to factor this trinomial though. So factoring that, just rewrite my fraction here on the left minus this fraction. So I'm going to guess and check. I need factors that multiply to 2x squared. So I'm going to pick a 2x and an x. That multiplies to 2x squared. And I need factors of 3. So there's only 1 times 3. So I'm going to choose to put the 1 here and the 3 here. I chose that because I noticed that 2 times 3 is going to be 6. And then 1 times 1x is going to be 1, and that will be able to help me get to this negative 7x. So if I had placed the 3 here and the 1 here, that's not going to work because that would be 2 and 3. 2 and 3 aren't going to get me to that 7 that I need. So we would have the sign here is positive, so that tells me both of these signs are the same. They're either both plus or both minus, and they both must be minus since we're adding to get a negative 7. So they would both be minus. Okay, let's go through our process. They both have an x minus 3 already, so we don't need any extra x minus 3s. This side has a 6, this has a 2, so we could multiply the 6 by 2 and the 2 by 6, but it would be the lowest or the least common denominator if we just multiplied the right one by 3, and now it's a 6. 3 times 2 is 6, which matches the other 6. And then it looks like this fraction, the last match we have is 2x minus 1. 2x minus 1. Okay, so kind of a lot of stuff going on here. Let's write this out. We have a 6. We have x minus 3. We have a 2x minus 1, and then we need to do a lot of distributing here. So that would be a 10x minus 5. Don't forget that subtraction. We have a 3x minus 3, and it's a negative. So negative 3x, negative 3 times negative 1 is plus 3. And then we can add like terms, so we get a 7x minus 2. And we have a 6, an x minus 3, a 2x minus 1. And again, we're not going to multiply that denominator, we're just going to leave it right like that, and that would be our final answer. Again, you'll do number 4 and number 6 as a try this. And I will see you in the next video when we look at a little more complicated adding and subtracting rational expressions. See you next time.